Welcome to the lesson about textile electronic circuits. This first video is focused on conductive yarns and tracks, that is to say, to the basic elements of electronic circuits. Three basic materials families are used in e-textile to make conductive yarns or tracks. First ones are the metals. The most used are silver, copper, and stainless steel. These metals are used to make fibers, plating on host polymer fibers, or on textiles, for instance. The second basic materials family are CPCs. CPC are conductive polymer composites. They are composing of polymer matrix and conductive filler. Of course, the aim of the blend is to be conductive. Thus, sufficient quantity of filler must be added to form conductive paths through the composite. Filler could be based on carbon. We could cite carbon nanotube, carbon black, graphene for instance. But metal particles or intrinsic conductive polymer could also be used. CPC are used to make fibers, conductive coating, printing, or 3D printing, for instance. The last basic materials family are ICP. ICP are intrinsic conductive polymer. They are polymer for which conductivity is achieved by p delocalized electron along polymer chain. The most used ICP are p-dot, polyaniline, named PANI, and polypyrrole, named PPY. ICP are used to make fibers, polymerized layer on host fiber, or textiles, for instance. Here is a focus about metal fibers because it is the most common used materials for the development of e-textiles. A lot of products are made from silver plate polyamide. These materials has an average conductivity around 1 to few hundred of ohm by linear meter of yarns. Processability is very good due to the polyamide core structure, and the cost is high and the durability is average. Of course, these outlines are dependent of the quality of the coating or plating, thus of the quality of the manufacturer. The linear conductivity is dependent of the count of the yarns, and the global quality and durability of the final product will depend on the process. The second focus is about the spin metal fibers to produce 100% metal yarns or blended yarns. These materials have a very good conductivity, around 1 to few decades of ohm by linear meter of yarns. Processability is average due to the rigidity of metal fibers. The cost is high and the durability is good, but dependent of the metal and of its oxidation, for instance. Again, these outlines are dependent of some parameters. We could cite the number of and the diameter of conductive monofilaments, which will influence the conductivity. The wire construction will be also impact the cost, the conductivity, and the durability. Unlike the silver plate polyamide, the global quality and durability of the final product will be dependent of the process. One of the possibilities of use is the integration of conductive materials in textiles. In this case, we must use conductive yarns and introduce these yarns in the process. All textiles processes are concerned, as weaving, knitting, and braiding, for instance. The result, as it is visible on picture, is a perfect integration on conductive tracks or electrodes in textile structure. The second possibility is the implementation of conductive materials on textiles. In this case, all conductive materials can be used as conductive yarns coating past, printing ink, for instance. Processes are more linked to finishing, as embroidery, coating, printing, or 3D printing, for instance. Some examples are visible on pictures. On the left, embroidery of silver plate yarns. On the middle, embroidery to maintain carbon fibers. On the right, a circuit board obtained by printing. The conductive track is more or less well integrated, and the textile characteristics of the final product are not always preserved.